So thanks to your friend for reminding me to record the lecture. This is going to happen a lot. I always forgot to record it, but all the lectures will hopefully be recorded, lectures, labs, and everything, except for of course, the exams. But other than that, all the lectures will be recorded. You will see the recording hopefully in less than 24 hours on YouTube, and then I will share it on the Moodle. Another thing also for the PDF lectures and all the slides, I make the slides in Canva, and so I will be sharing with you like the interactive Canva link. But because of some issues with VPN and Russia restrictions, you might not have access to that very well. So I will also be sharing the PDF and the interactive lecture slides, as we said. The whole lectures will always be done on Zoom, as we said, and the midterms and the final exam will all be on Zoom. It will be completely online. And what you will have to do is just simply share your screen at every second and keep your mic and camera on during the exam. For that, you will have, of course, to each be in individual breakout rooms. I will handle all of that organization. And for the lectures and labs, if you want, you can turn on the camera to feel, just to feel a little bit of a human touch into the lecture. But if you feel a bit more uncomfortable, or if you feel that it's not something that you want to do right now, absolutely feel free to keep your mic and volume off, video off. We have another question. We have one lecture offline on the 27th. That is, I have no idea what that is. Yep, so I'm definitely not going to be able to come to Russia anytime soon. And on the 27th of June, if we have a lecture, for me, it's 100% going to be online. Probably this is this might be like some midterm or something that they wanted to prepare a room for. But for me, it's going to be all of you guys in your home. So nobody's going to go to the university for this course. So before we go into like the course content and everything, the course is about just applied machine learning in general. We will speak heavily about things like computer vision and natural language processing, but also about things like deploying machine learning models and how to use machine learning models. A quick self-introduction. My name is Bikush Imaduddin Ibrahim. You can call me immediately by Imad. No need to use sir or professor or any of these things. Just say Imad directly, and that would be me. My education background, I've done my bachelor's in computer science in Algeria, a master's in data science in Annapolis with the rest of you guys, and a PhD in AI from Sorbonne University in Paris. And here's a beautiful picture of the Sorbonne University. My work experience, I've worked a lot with Innopolis Research Labs as a researcher, and we've published some articles. I've worked also with Provectus, which is used to be in the what is that called? Inotech? I forgot. What is the name of the
Technopark.
Technopark, yes. So it used to be in Technopark, but sadly now it's no longer there. And now I'm working with PepsiCo as, a team lead for their data science European team. Yeah, one other thing about me, this is my first time doing this presentation on what is it called? On the iPad. So it's a little bit uncomfortable. Let me try to change this a little bit to make it a bit easier. Let's see. Okay, this looks maybe a bit better. Let's do the share screen. I think now you can see at least the full thing. Why am I doing it on the iPad? Mainly because since we are doing it online, it's very difficult for me to just draw something that is humanly recognizable through the Mac. So the iPad is going to be our whiteboard, let's say. So that's it for me. Mainly, my research interests are computer vision, domain adaptation, and knowledge graphs. If you have no idea what these things are, it's absolutely not useful for this course to get introduced to these things. But if you'd like to ask me some questions about research or anything else, these are the topics that you could feel free to ask me. Anything else, I would probably just be as good as a Google search. If you want to contact me, there is the Telegram. I'm with you on the Telegram channel, so you could either contact me there, or you could just contact me directly. I respond usually pretty fast. Or you could use my email. Sadly, the Innopolis email, because of the restrictions and everything, I'm unable to access it well without a VPN. So if you need something urgent, just contact me on my personal email, and it should be I should be able to respond. So before we go any further, it would be nice to get a quick introduction to some of the students that we have here. Maybe where are you from? What's your name? What are you studying currently? What are your interests? Do you want to continue doing research, or are you more into the industrial and applied machine learning? Yeah, let's go. Let's see who's brave.
Okay, can I start then?
Absolutely.
Yeah, so hello, my name is Daniel. I'm studying at Annapolis University at the second course, as everyone is, I think. And I'm pretty interested in machine learning. I don't have much experience in it though, because we just had one semester of it, but I'm interested in it really like a lot. And I'm more into industrial stuff rather than research.
That's amazing. So just a quick question. You said you're in the second year, so that's before the specialization, right?
No, we already selected one semester ago.
Oh,
so it's a bit different for us.
Yeah, what is it? Your specialization?
Yeah.
Did you choose data science or robotics?
Yeah. Okay. No, applied artificial intelligence.
Oh, that's pretty cool. That's nice.
Yeah.
Thank you so much, Neil. Anybody else? You're from Russia, right?
Yeah.
Nice. Any city that I might recognize?
May I?
I'm from Perm, but there are like Moscow and St. Petersburg in Russia, I think you know.
Yeah, that's it. Thank you so much. Okay. Yeah, you can go. I'm not sure who said it, but yeah, you can go.
Okay.
Hello.
Hello.
Yeah.
Okay. I'm the second. Thank you. Okay. Okay. Hello. My name is Georgy Budny. I'm from Vladivostok. Now, currently, I'm studying in the Innopolis University, and too, of course. And I have specialization in applied artificial intelligence. Maybe my major. My major, maybe it's about machine learning and explainable machine learning and explainable artificial intelligence for some business processes. Yeah,
that's amazing. So you're more in the field of applied interpretability, or more research on how to interpret?
More applied. More applied. Yeah.
Yeah, that's nice. So who's next?
Okay, do you hear me?
Yes.
So, okay, my name is Elnar. My specialization is software engineering, so I'm imposter here. But I liked machine learning in previous semester, and suddenly I work at AI Lab, and I create a backend for products where there is a machine learning used. So that's why I decided to choose this course.
That's pretty interesting. This is gonna make for a great team if you want to do like a team with the data scientists. But just a quick question: you said software engineering, so is it more web, mobile, or good old desktop apps?
Before previous semester, I worked mostly in web, but when I applied to AI Lab, it's not neither web nor mobile. It's like building the whole product that is built on the servers.
Yeah, that's pretty cool. That's awesome. Nice. And you personally, are you interested in something else? Are you interested in web or in mobile?
Yeah, web.
Web, that's nice. Okay, that's good. Good to know. Anybody else?
Yes, can I continue?
Absolutely.
Okay, my name is Vladislav. I'm from AI Group 2. I'm not imposter here. And the thing is, why we have already chosen the specialization, because we are speedrunning the Innopolis courses, because we are 3+1 program. So we study 3 years and why 1 year of work after
Ooh,
that.
nice.
Yeah, that's why. And I am myself really into applied artificial intelligence, like in industrial cases, hackathons, and some fields that are not really popular here. For example, federated learning or something. And I'm into like learning a lot about machine learning, so that's why I chosen the IML course.
That's amazing. Nice to meet you, Vladislav. That's pretty good.
I am from Perm too, as the first person to introduce himself.
Oh, I have to Google Perm then. Perm, right?
Yeah, definitely.
Yes.
You have to visit it.
Visiting maybe next year. Maybe next year, hopefully. But let's
Okay, we're waiting.
see. Thank you. Oh, it's a very beautiful city. Yeah, I see. Ooh, nice cathedrals. Nice. Anybody else?
Yeah, thank you.
Yeah, go ahead, Hamada. Yeah.
Hi, my name is Hamada Salhab. I'm from Syria. Also in the applied artificial intelligence specialization. Mainly, I'm interested in computer vision. I've done some project when I was at high school in computer vision, but they were not very sophisticated. So I'm looking forward to leveling up my skills with this course, just to get more in touch with that field.
That's amazing. That's, you are
Yeah,
from,
thank you.
are you from
Yeah,
that
Syria.
high school of excellence thing?
Yeah, National Center for Distinguished, yeah.
Oh, usually those guys are extremely smart. Yeah. That's
Yeah,
nice.
thanks.
And where are you from in Syria?
Latakia.
Laqiya.
Yes, exactly.
Yeah, that's pretty cool. Yeah, that's
Yeah,
nice.
thank you, thank you.
You? Anybody else? Nobody from robotics here? Usually we have a lot of robotics people.
Okay. My name is Yasha or Yakov. I'm from robotics track. Yeah, I just chose this course because I don't know, others seemed not like interesting.
Nice.
Yeah, that's why.
Nice. I hope it's at least a bit interesting to you. And do you plan to learn a bit more about theory or more practice?
More practice.
Teacher, that's nice.
Okay, thank you.
Thank you. You didn't tell me where you're from, by the way.
Russia, Perm.
From Perm again.
Yeah.
Oh, that's good.
Most partial Perm group.
Yeah. Well, welcome everybody. So I think we've got like a good intro to the majority of the students, and I had like a small vision about the students who are here. If you feel like you are from a different background, you could tell me right now. Maybe there's
yeah, I think I can. Yeah.
security.
Yeah. Can you hear me?
Yes, absolutely. Go ahead.
Yeah. So yeah, I'm Igor Abramov. I'm from Chelyabinsk, and so I started doing machine learning and stuff like 3 years ago in school. I passed a good course from MIPT, like Moscow Physics University, and like I was pretty amazed by the neural networks and stuff, because like especially for generative AI.
Yep.
Currently, I specialize more in computer vision. I won 3-4 hackathons, and currently I'm one of the founders of startup.
Wow.
That's like based on computer vision.
That is absolutely wonderful. Nice to have you. Yeah.
Thank you.
I'm gonna have some high expectations.
I'm
gonna have some high expectations for you.
Thank you.
So welcome. Do we have anybody from security, right? from those security specialty. Yeah, I never have anybody. Yeah, they never come to my courses, sadly. Well, nice to meet you guys. Nice to meet everybody. I hope this will be a pretty chill course. So majority of like the courses that I teach are pretty chill. So you're not going to have a lot of stress for things, for example, such as the homeworks. If they coincide with some midterms or some exams from other courses, just tell me, I will give you an extension. In terms of, yeah, for things, for example, if you can't get the homework on time and you feel like, so there's no other reason besides like personal reasons, then don't worry, just submit it whenever you feel comfortable. And I will grade it at any time, right? As long as it is before the final grades, you can feel free to submit your homeworks even at the final day of the course. Preferably don't wait. So some prerequisites, I'm sure you guys have done a little bit of linear algebra, some calculus, a bit of statistics, and some machine learning. I'll take that as a yes. For the machine learning part, I know you guys are like second year students, so probably you did not take did you take the Professor Adil Khan's course on machine learning?
Yeah, we did.
Okay, so you have everything that is needed, right? It's one of the best courses that we got in Nautilus. For practice, I hope that everybody knows at least Python. Is it all good?
Pretty good.
Nice. Algorithms and data structures. And if you have some NumPy, Pandas, and sklearn experience, then you are already too good for this course. For the grading criteria, there will be like 50-50. One will be for the projects, half will be for the projects, and half will be for the quizzes. The quizzes are super easy. They are usually just like 30 minutes quizzes on Moodle. Very easy questions straight from the lecture. If you attend, you will get 100%. So this 50% is like guaranteed for anybody who attends the course. This quiz is 50%. This is almost 3 points for the students who attend. And then we've got the projects. This is where you will shine, right? This is where you will define whether you have an A or a B. For this course, the majority of the students will have A or B, unless you had like some you did not submit any homework, you did not come to some quizzes or something like that, then yeah, maybe then you will get a C, but nobody should ever get a C in this course. This is a course that you will either get a B or an A. And your A will be definitely determined only by your projects. 25% of the grade will be for the homeworks. So we will have 2 homeworks. One, we will have basically, let's see, to this lecture. So starting this lecture, we can roll it out if we finish early. And the next one, we will get it after 3 or 4 combinations of lecture labs. For the quizzes, you will have a midterm exam which is called a quiz number 1 for 25% of the grade. And for the final exam, which is in the end of the course, you will have also 25% of the grade. The final exam will touch on all the course content. So it's not going to be about only the final few lectures, but all the course content. Sorry. Let's go. Yeah, so the course structure will be about lectures and labs, right? As usual, everything will be online. The evaluation for the lectures will be MCQs, multiple answered questions or something like that. It's in French, so it's going to be hard for you to translate it, but it's basically just the quiz on Moodle. Labs will be also online, and they will be project-based evaluation. For the outline of the course, we will see different things. So the outline is definitely not fixed yet. For now, I'm using the same outline for the master's students, but definitely you're not going to have the same experience as them. So we will have to switch a little bit around the content. So I propose we take like a quick break for 5 minutes, and then we start with the actual course. All good?
Yeah, thank you.
Yes.
Okay, see you guys in 5 minutes.
For your knowing, we see your slide shifting.
Yeah, I'm just checking the course outline and stuff like that, just for when we come from the break, we have them ready. By the way, does this screen size like fit everybody, or is it a bit too big?
Seems fine to me.
Okay, then all good. Enjoy the break. We still have 2 more minutes. Get some coffee.
Yeah, our light turned off, so we're just waiting until it turns on. Like the whole dorm is, there's no electricity now.
Oh wow, that's hard. Do you still get those like fire alarms randomly at night?
Yeah, of course, it's like basic.
The fun. Okay, nice. Just had like a quick question. This is, I know, the like 12 a.m. for you or 12 p.m. for you. So not sure if it is, if you guys have enough time to actually go eat. Did you go eat?
Yeah, we have a lot of time before, so
Personally, yes.
Okay, so you,
Come on, that's online course. We can eat right now.
yeah,
Yes.
also.
I agree. Yep. So for those who, for example, still eat at the university's canteen, or maybe they need some time to eat, you could just text me and you could take some time off. Okay.
Sure.
Perfect. So yeah, let's go. Yep. Share screen. Okay. So I hope you guys can see the screen right now. For the content of the course, we will, as we said, we will start this is not finalized yet, but we will be speaking about, in general, practical machine learning applications. And why can I? No, yeah, like this, okay. So we'll start speaking about things like what is the machine learning pipeline and how to manage the project, machine learning projects, what are the steps of building a machine learning model. And we will discuss on the lab side, what is the concept of transfer learning. We'll speak a little bit about object detection and how to perform object detection. So we will go into detail about the architecture of RCNN. So this is going to be very heavy on the theory side, but it will be pretty easy to understand. It's even if you have no background in computer science, you'll be able to understand it. We will also go into detail about the YOLO architecture and speak about its theory. And for the practice part, I will basically experiment with using either one of these, and it's up to you for the homework which one you want to use. You will see that it's very difficult, very easy to switch between the different versions of object detection models. We will also speak about adversarial machine learning, which is basically the reason why GANs were very important back then. So things like GANs, we will go in depth about these concepts, and we will speak about a little bit also about diffusion models and how they are trained. So for the GANs part, I'm not going to give you extreme details because you will have this detail in future courses, either by Professor Fahim or by Professor Khan. So from my side, I will just be explaining mainly the adversarial part and not the generative part of GANs. We will also speak a little bit about transformers, either for natural language processing or for vision transformers. If you want, we could skip the natural language processing part and replace it with prompt engineering instead, because the natural language processing course, you will have it with, I think, Professor Fahim again. I'm not sure. Yeah, it's definitely with Professor Fahim. And for the robotics students, if they want, we can also discuss Kalman filters because they're extremely important for their work. Also for data scientists, if you are going to work with financial data or you're going to work with, such, changing data sets, sequentially changing data sets, then Kalman filters are extremely important for these fields. The other two sides of the coin will be evaluation and interpretability. So I've heard one of you guys is very much interested in the interpretability part. For the evaluation, we will speak about things like regression, classification evaluation, and object detection evaluation. As you might guess, there are very different techniques, very different tasks, and their evaluation also will be pretty different. We will speak a little bit also about a basic interpretability for machine learning models, such as linear regression or any linear model or any decision-based model, such as decision trees or random forests. And then we will definitely speak a little bit about A/B testing. So quick question, why do we think that A/B testing is important for the evaluation? So how can you relate these two topics together? So first of all, did you guys know what A/B testing is? I'm sure you guys did it with Professor Suchi, but just to confirm.
We don't have some switches lectures, but I guess A/B testing we need in it because we need understand how our model, how our program works on the real data.
Absolutely.
And how it works, yeah, on the real.
Absolutely. So for example, you're building a computer vision model that takes the picture of a person and then generates the picture of that same person in different types of clothes, yes, your model works very well. It segments the image very perfectly, and then it, applies some generative model very well. So your perfect evaluation that happened here on this side just gives you very amazing numbers. But then when you start using it, you realize that, I don't know, for some reason, it is dropping the sales. The only reason that why we want to include such machine learning models in our websites or in your business is to improve some metric, is to make more sales, is to make more money. So evaluation must be done on two steps. The first step is to evaluate the actual model. So does it give good accuracy? Does it segment the image well enough? Does it work for edge cases, etc., etc.? But the most important part of the evaluation will be the A/B testing and verifying that your model actually does its work or does its job when it comes to increasing sales or increasing engagement. So for example, Netflix is experimenting with a new recommender system. Does that recommender system provide more overall satisfaction for our clients? So that is the main question that we want to get answered. And that is the only evaluation that matters for machine learning models. Do these machine learning models answer the business question that they were built for? So as you see, we have two types of evaluation. The first one is, the classical evaluation that I'm sure you guys at least know these two parts. But the most important type of evaluation will be the A/B testing that you will perform for your clients or your business needs. Last part of the course will be about deployment. So this will be important for all of you guys to have on your projects. So any project that will not be deployed will not have the full grade, right? So don't aim for an A if you do not deploy your model. Deployment will either be on RESTful APIs. You could deploy it on some Docker containers and then integrate it with Kubeflow as you wish. All of these things are up to you. You could deploy it on the edge. So for example, if you are, as a friend of yours who is working in software engineering, he likes, websites and stuff like that. So you could deploy that model on the edge directly on the browser instead of deploying it on some server and then it interacts. And then the final one would be to just give us a simple Streamlit app, just so that everybody can use your model very easily. And this will be extremely important for you guys who will probably go and pass some interviews or stuff like that. It's very nice to have some way of interacting with the models that you guys have built. So this is overall the structure of the course right now. As we said, this course was built for, master students or, somebody who might have a little bit more experience on these topics. So for me, I assume that they all know convolutional neural networks in depth and they all knew so for example, natural language processing, I didn't expect to be teaching things like RNNs or LSTMs, so we went directly to the transformers. But with this course, since you guys are all second year students, we might want to go a bit more into details about the basics of machine learning, and hopefully we will revise them together in a very comfortable yet useful way. Very beautiful city, by the way. So if that sounds good for you guys, and you might not have any questions. Do you have any questions about the course content so far? All good?
Yes, no while.
Yes.
Nice. So if that's all good, then let's go to the first part of the lecture, which is the deployment side of machine learning. So this is a beautiful book in here that you could, it's like 33 pages. It just gives you like a quick intro to what is data science, why should you want to do data science, what are the jobs in data science, right? So what are the different careers that you could pursue in this field? There are data engineers, data scientists, data analysts, you name it, you will find it. So here you find, for example, something, let's zoom in. So here you find something like, what is a data scientist? It explains a little bit how to become the data scientist. What are the most important things to have to call yourself a good data scientist? So what are the tasks that you could do? So you could work in economics, you could work in natural sciences, statistics and mathematics, computer science, engineering, data science, and analytics. Some of the qualifications, Python or R, SQL is extremely important. Experience in MATLAB may be a little bit questionable. Advanced practical knowledge of data science, excellent analytical and learning skills, deep learning, a little bit TensorFlow or PyTorch as you wish, and some NLP and its advances. Practical skills that you could have, integrity, these are like pretty common for everything, but something extremely important is strong written and verbal communication skills. So, me personally, I'm like with PepsiCo, majority of my work is at this level, just making sure that I'm communicating in a very clear and very strong way, both written and verbally, through emails, through PowerPoint presentations, a lot of Excel stuff, a lot of Power BI stuff. So it's really about communicating your findings, right? So data science as a science, it's not about finding important information or building different models. It's about communicating important information that you were able to gather from the data, right? So you're able to guide basically people like sales teams or people like, the sales teams, for example, so they can make better decisions that influence their sales and improve, just basically make more money for the company, right? That's what data scientists do. Data analysts, on the other hand, they're just more about focusing on, understanding the data itself. So giving you some statistics. Remember when we had the COVID, everybody was talking about like the number of deaths per day. All of these things are data analysis things, right? So here, mostly it's going to be very similar, but we focus a lot on working with SQL data sets, on Tableau, Excel, and these kinds of data sets. So you focus more on the statistical part. And again, communication is a must. If you will choose data analyst versus data scientist definitely is better in terms of like monetary reward. Business intelligence analyst also is another good career, but again, it's a little bit less of a salary compared to somebody like, data scientist. And here you can find lots of more information. How to...
Okay, I found this on the web.
Sorry, guys, that was...
No need to.
Oh.
Hello.
Did you guys hear me while I was speaking? For some reason, Siri interrupted me. Yeah. Did you hear everything or?
Yeah, we heard.
Okay, that's nice. So again, another field of work which is pretty interesting, especially for the software engineers, is data engineering. And these ones are also very well paid, and you will find more jobs in data engineering than in data science per se. So for example, your team might need 1 or 3 data scientists, but we'll need, for example, a whole department of data engineers, because working with data is really, really hard, right? It just takes a lot of manual labor. So here, definitely you're gonna need a crazy amount of experience about things like SQL, data processing pipelines, and big data understanding, like Hadoop, how to use AWS environment, how to use maybe Azure, and all of these things. So it's pretty big field of work, and it has a lot of jobs, right? So more jobs are available in this field than in any other data related job. There's another one which is data architect, and usually these ones are very hard to get hired, but once they get hired, they are paid pretty well, mainly because you need just one very good one in your company, and they will be a very, very big guy in the company here. So, some of the technical skills are very strong data modeling skills, database architecture. So they will define the data. How does data work in your company? Basically, where you get it, how you store it, how you duplicate it so it doesn't get lost, how you provide it in a very fast way to the people who will use it, optimize all of these questions. It's up to you, right? Data governance know-how. So for example, if your data is EU related, you should never store it in the US, or else you're gonna get some lawsuits and stuff like that. So this is the guy who must know all of this information. Job outlook, as I said, the demand is rising, and a couple of more information about some good certificates to have. and some of the fields that you might go into. So that's it for overall what data science is in, in real life. What are the different careers that you might want to pursue? For my side, I will be mainly preparing you guys for the data scientist job. But if any of you, especially software engineers, want to go with the other side of data engineering, having the information or having the this knowledge of how machine learning models are trained or stuff like that will help you become a better data engineer, right? And a data architect, if that's what you want. But now let's go to the second part, which is how do we get from an idea or a problem into an actual machine learning model and then into an actual solution. So here we will start with this first point of machine learning pipelines and project management in general for machine learning projects. So there are very big master's degrees in, MBAs specialized for data science degrees. So we're not going to be able to cover everything, how to work with a Jira board, how to work with Trello, how to communicate well, how to build, the pricing for your model, not the model, but for your team and all of these things. So we're not going to go into that level of the depth, but you as a data scientist at least must know all of these different steps. So you must be an expert at understanding the business problem that will come to you, and you must formulate that problem in a good way, right? The majority of the problems that you will receive, sadly, are not machine learning problems. So somebody might come to you and say that, oh, did we get a good, I don't know, Netflix changed their pricing strategy? Was that a good option? Was that a good decision or not, right? So this question is not really a machine learning question, but it is a data science question. So you could do things like A/B testing and other things like that, but it's up to you to basically understand whether the thing that they're asking from you is a machine learning problem, is a data science problem. So as we said, things like just statistical tests and basic statistical modeling, or is the question that you're being asked is basically just something that you could implement using basic coding, just if and for loops, and you get that done. So it's up to you in this level to speak with business people who have no understanding of what data science is or what programming even is. And it's up to you to decide whether that problem is where it belongs and how it should be solved. So going from a business problem into a problem formulation in a machine learning way is a very important skill to have. And then, of course, we have the steps of a machine learning process, which is very easily collect and label data. Data comes in multiple forms, but the majority of the data that you might be working with, especially if it's in a big company, will be just internal data or data that you buy from data providers. Or if you are just a small startup, there are hundreds of public data sets that you could use, or you could build your own data set. In this course, you will all be forced to basically build your own data set from scratch, label it, and basically, just do the collection and labeling from scratch. So as we said, for the collection and labeling the data, we have multiple sources. One is public data, second is private or in-house data, and the final one, it's the data that you buy from data providers such as Facebook, or for example, Nielsen TV, or some Nielsen or IRI data providers. These are basically companies that specialize in very basic job, which is data collection. Some companies, like for example, Nielsen, as we said, they provide you, or OMD, they provide you with data about the price of your product on each individual market. Every week, they give you an average, and then they aggregate all of that data. For example, if you are, I don't know, you are Netflix and you have some competitors like Hulu or Amazon Prime, they can tell you if they are doing the promotions, what are the promotions of Hulu, what is the price of Hulu, what is Hulu providing. So all of this data information, you might get it from either public, in-house, or a data provider, so you will have to pay a lot of money for it. And this is something that you all must know, because you will be making the decision of requesting that type of data, or you will be making the decision of labeling new data sets and creating new data sets. Data evaluation is very simple. Data feature engineering is also very simple. For the majority of the data scientists, you will not be doing this job. So this is the job of data engineers. This is the job of data architects. For you as a data engineer, you must make sure that the data comes in a very good format. So for example, while working on the global PepsiCo, what is it called, data science, we have one problem, which is the US is always using different types of date formats, different types of measurements, different types of, for example, the dollar. Here you have the euro, the other one you have the pound. In India, you have another pricing mechanism. So the data engineer, or the this part of evaluating the data and feature engineering, is very important because it standardizes kind of the data sets that you are using. Make sure that all the dates are in the same format. Make sure that all the, for example, missing data is handled. If you have some new combination, so for example, you have information about the time and the distance. So a good feature that might be included would be the speed. So you know the formula for how to calculate the speed based on these two metrics, and you could include an extra feature. This is in the feature engineering part. So you include an extra feature for the speed, and you provide it to the models. Next step would be to select a model and train it. So you will here perform multiple what they call training mechanisms. So majority, you will start with something very simple, and you increase the complexity of your model. This is the first step, which is the classic evaluation of the model. If it doesn't meet this requirement, you go back, tune the model, or select a different model, or it's up to you, select a different feature engineering technique. You fix some new features, you change some feature names, some features, for example, with the costs. For example, sometimes you might use something like cost per liter if you want to use a cost per impression or cost per a GRP. These are like different types of feature engineering techniques for specific data sets. And it's extremely important to work very closely with the business people, because you as a data scientist, you will be applying this strategy for every type of data set, but you don't know some of the things that are extremely important for that field of work, right? So for example, if you are working with marketing, then you will need to ask them, how do you combine these features? How do you calculate a new feature that could be an indicator for inflation? How do you calculate stuff like that? So feature engineering is extremely important, and you must always do it with what is happening right now, with the business people. If everything is working very well, and for some reason my screen is exploding, but if everything goes well, you go to ask yourself a very simple A/B test. Does my product meet the business goals? If yes, deploy it to all your users. If no, go back from the start, either to some feature engineering and feature augmentation, or into basic data augmentation. Just get more data. Your model is just not good enough yet. And it's not a problem of the model or the training, it's just you don't have enough data, right? So the final step, which is, as we said, the A/B test, this is what defines whether your model will go to production or not. And this is not something that you can easily skip. So most companies, they skip this, and they fall for very, very harsh landing. But even if you are working as a startup, you always have to include this step. Just do this step, it's extremely important. So this is mainly it for the first step of, of the ML pipeline in general, and how do you deploy models in computer science or in data science. It's a quite interesting field, but as we said, we're not going to go all completely into detail about these concepts, but we might want just to do a quick recap together. I'm sure you have seen all of these information, but just to make sure that you guys already know all of these steps. So, the business question, some of the questions you might ask: how is it done now? What is a success for the business? The problem, intended outcome, and very clear measurable results. how the solution will be used. So how will the user interact with it? Do other solutions exist? Do we have something else? Do they have like some metric of success? What are the assumptions that we're working? So for example, are we working on mainly Russian people, so white skins, or are we building this one for a global clients, meaning you will have some Indians, you will have some Black people, you will have some Asian people, you will have some, Netherlands with like extremely white people. So what are the assumptions that you are making about where your model is going to be used, and assumptions also about the data that you are provided? Who are the domain experts? This is extremely important for the feature engineering part, because you will ask them about like some domain specific knowledge, and that's the thing that usually increases your model's performances the most. It's not going to be tuning your model or changing your hyperparameters or increasing the learning rates that's going to give you the most increase in both the A/B test results and the evaluation results. It's always going to be domain expertise and feature engineering. Framing the problem, you have to ask yourself, does it actually need machine learning? What kind of machine learning it is? So we will be seeing things like supervised, unsupervised, semi-supervised. Does it use some regression, classification, segmentation, or object detection? All of these questions must be answered beforehand, before writing any code, right? So you see this process, it's really time consuming. And actually, when you ask all of these questions and you have the answers and you have a very clear document that describes all of these answers, the actual code becomes very easy to write. Do you have the data? Where are you going to get the data? What type of data do you need? And what is the simplest way to do it? Does it need to be a machine learning problem, or does it just require a couple of statistics and a dashboard, right? Collect and evaluate the data, sources of data, as we said, private data, public data, commercial data that you buy, and scraping the web, just verify that it is legal. Data consideration, what data do I need? How much data do we have, and where are we getting that data from? Access to the data and the centralization process, representatives and minorities. So for example, we said you're working with mainly Russian people. If your model is going to be used on somebody who is Black, make sure that you have some training data for Black people too in your data collection process. Identify your features and labels. What are the features and what are the labels, and what is the relationship between them? Understand if there are some correlations. And most importantly, always ask a domain expert. Are we good so far about these concepts, or do you have some questions?
No.
Okay, very well. So let's go to the next step for the pipeline. Feature engineering pipeline. Majority of the work will be feature extraction, feature selection, and data prep. Some domain formulas, as we said, you might have things like speed. You could include the speed formula. You might have some other very more complicated formulas if you're working in some physics or something like that. Or if you're working in the field of marketing and sales, they have hundreds of formulas that you could add, and they will help 100% improve the results of your model. One-hot encoding. So are you guys familiar with the concept of one-hot encoding with Professor Khan?
Yeah.
Nice. So for one-hot encoding, you have two techniques. One is for categorical variables, and the other one is for nominal categorical variables. You would just use one-hot encoding. Or if you have some ordinal categorical variables, definitely go for the label encoding part. Nominal categorical variables means that the classes have no relationship between them. So for example, a donkey, a horse, and a monkey, and a dog, you can't really order them as 1, 2, 3, 4 without including some information. So you could order them based on the weight, you could order them based on some other information, but you lose some information and you add some more information into that variable. If you want to make sure that that encoding remains as correct as possible, the only way to encode a nominal categorical variable is to use one-hot encoding. Now, on the other side, if you have ordinal data sets, such as, for example, grade A, grade B, grade C, grade D, you already know what is the order. So A is the highest, B is the second, C is afterwards, and D is after that. So you have some order inside this categorical variable. And for that one, you will be using some label encoding, things like 1, 2, 3, 4, 5, instead of something like 0, 0, 0, 1, 0, 0, 0, right? For imputing, of course, you will have a lot of not a number variables, and you have multiple techniques to fix that. Replace mean, replace mode, replace median, or just completely delete that feature, not feature, just completely, yeah, either completely delete the feature or completely delete that role that you just cannot use. Don't forget about handling outliers. It's very, very hard to do that. And never forget that you will have some very weird outliers. For example, we work with a lot of spend and impressions data, and sometimes you might get some value from Facebook that says your ad has received 100 billion views last week, and that's just impossible. And it's probably just a copying error or some exception. So always remember, never trust your data and always handle outliers. Scaling and normalization is definitely also a very big important part because it allows your model to train very well, and it helps you escape that problem of exploding gradients or vanishing gradients. And also for basic linear models, it allows all the features to go into the model without an assumption on feature importance, right? Some of the models in machine learning that we will be working with take the concept of variance as a concept of importance, right? So it's from the way that they are built in the the mathematics that is behind that model considers a high variance feature as a high importance feature, and it will focus on that feature. But you don't want that, or of course, if you want that, then it's good. But if you don't want it and you want to assume that all features are the same importance to the model, then remember to do some scaling and normalization. Feature selection part, either you will filter, either you will wrapper something, or you will embed it. I forgot what these things are about. I forgot. Yeah, so basically, for example, if you want to keep, as we said, only Russian people in your model, or you would like to just do some more in-depth filtering and processing. Data prep, standardization of strings, standardization of things like dates and all of these things, normalization and scaling, missing data and outliers. Always remember to fix all of these issues. For the training part, remember to do train test split so that you can objectively evaluate your model. Remember, overfitting, underfitting, always verify for it. Choose a model and run it. Do some data augmentation and hyperparameter tuning. All of these steps must be taken into consideration when you are building the expected or the timeline of your project. So all of these are different steps that must be taken into account. Evaluate and tune, and of course, the final one would be deploy. Previously, the deploy part was the hardest step, but now thanks to Google and AWS, they made so many amazing either frameworks or tools that help you with the deployment and monitoring. The ML stack, data training, deploy and monitor, as we said. Yeah, these are more AWS specifics, but here you can see different compute instances and how you can run your model or basically train or deploy your model. The majority of the work will be done on EC2 instances. Here are a couple of some managed services that you could include directly. We're not going to go into them in detail. And if you are going to be either a data scientist or somebody who's working with data in the field of or in an AWS environment, then understanding SageMaker is very important for either for your interview or for your actual work, right? But that's it from my side about these concepts, right? I'm not going to go into too much depth about it because I'm assuming you've done or all majority of them with Professor Khan. And for those that you have not done, you are still too young to actually go into these things. Can you share with us this mind map? Of course, yeah, of course. We will be sharing all the mind maps together, and hopefully, if we manage to do it, we only usually manage to do these things when we're doing a class in real life, offline. For online classes, it's usually hard, but if we can, we will always be building a mind map together of the things that we are discussing. So we will be collaborating and hopefully building something that allows for easy revision and most importantly, allows for easier, like when you go to the job, an actual job, and you are faced with a problem, you don't need to memorize all of these steps, and you will certainly forget one of these steps. Mind maps are extremely important to get you up and running very quickly, and you have a timeline, you have everything done, prepared, you get working very, very quickly. So if you don't mind, let's take another 5 minutes break and we start our first actual lecture, which is going to be about basic image classification and with CNNs. This lecture is going to be split into two parts. We'll first speak about basic concepts, regression, classification, just to make sure that you have all of these things covered: linear regression, logistic regression, what is perceptrons, what is multi-layer perceptron, what is neural networks. Then you go to CNNs, and we will see how to train CNNs in depth, right? But we will go with it at the speed that is most comfortable for all of you guys. So as we said, I'm not going to assume that you know these things extremely well. Sometimes we finish this lecture in 15 minutes. Sometimes this lecture takes more than 2 sessions, or like 3 hours, basically. So it's up to you. I will go with the speed of your understanding. And if you have any questions, always stop me while I'm presenting, okay?
Got it.
All good. Yeah, just a quick question. So we have 2 sessions together right now, not just one.
Yes. If it's the question, answer yes.
Yes, and the first one starts at 12:50 and ends in like half an hour from now, and then the next one starts then, right? And we have how much of a break do we have between them? Okay, let's see.
10
Monday.
minutes, Sarika.
Okay, 10 minutes. So I think 10 minutes is good enough, right? It's a good period. So for us, we're going to completely ignore the fact that they are 2 complete different sessions. What we're going to do is, whenever we feel tired, we take a break, okay? Whenever you feel like I'm speaking a lot and nothing is going in, we take a break. Doesn't matter if it's not part of the 10 minutes break, doesn't matter if it's too much, doesn't matter if it's too short. Anytime you feel like you're not getting in the information, take a break and we come back, okay? Perfect. So let's see you guys in 5 minutes. Get some coffee. All right, so let's get back to the lecture. Everybody's back, everybody's ready?
Yeah.
Yep.
Nice. So as we said, during this lecture, we will speak mainly about computer vision and especially the image classification side of computer vision using CNNs. Before I go into the lecture, just want to ask you a question. What do you guys know about CNNs so far? Well, what kind of courses did you take about it? Did you work with it? Any idea like that?
The part of ML course from Adil Khan had like 1 or 2 lectures about CNNs and like good practices about CNNs, dropouts and polls and other stuff.
Oh, nice. So you did at least like 1 or 2 lectures about CNNs.
Yeah, and we had a part of our assignment considering the CNN, like the image classification or something.
Yeah, in addition, we have more than 2 lectures about CNN networks. And as a result, yeah, we have a fingerprinting assignment about classification of some pictures, so data augmentation, etc. We understand about some tips from the course, basic course, yeah, and use it a little bit.
Perfect. So I'm guessing, did you also take things like variational autoencoders and stuff?
No, we didn't have it in the course.
We had it. You had it.
No, we didn't.
Okay,
I
nice.
think.
Okay. That's good. So yeah, so I think this lecture will go pretty quick then, and we will go into the lab directly. But overall, we will be discussing neural networks in general, and then we'll discuss CNNs in more detail. So before we begin, can somebody tell me what is the difference between classification and regression? And someone else could give me some examples of regression and some examples of classification. Easy question.
Yes, can I try?
Absolutely. Yeah.
Classification is task where we have some amount of finite amount of results that can be get from the model or task. Like for example, we should decide on this picture, is it a cat or a dog? And regression is a task where we need to give some amount, for example, how much money will this house will cost?
Yes.
Based on its location, its area, and other things related to the house.
Absolutely. So as your friend has said, one part, the classification part, aims at classifying into specific categories or predicting a specific category, whereas the regression side aims at predicting a numeric value, right? And she did a very good job, but also providing some examples for classification and regression. But can somebody give me an example of classification? Another one. Classification, nobody? Okay, we have some in chat, nice. Road sign classification, absolutely. Can you give me another one for regression?
Predicting price of location of the house.
Nice. Now let's make a discussion about something like temperature, predicting the temperature. Is it a classification or a regression? And is it both? Or can it be done in both? What is the, how can we treat it as a classification and how can we treat it as a regression, and which one is better? Go ahead.
Not only about the temperature, more about like weather at all. Temperature is more regression task, and we can say our task, for example, if will it be snow or rain or sunny? This we can be also made by classification.
Yes. So for example, if I say 10 degrees, if I predict 10 degrees or 20 degrees, this is clearly regression. But if I say today it is hot, today it is cold, today it is warm, all of these are adjectives. These are categories. So even the same concept of predicting the temperature or the feeling of the temperature, you can define it as a regression, you can define it as a classification. And who answers the question if this is a classification or if this is a regression task? According to what we have just seen right now here. Who can tell you what to do? The business people. The business people will tell you whether this will be used, whether your model is going to be used as a, I don't know, as a Siri thing, like part of Siri, you just say, hey Cortana or something like that, and how is it going? How is the weather today? And she will just say the weather is going to be cold today. She's not going to give you the degree, or she's not going to tell you it's 0.5 something. So it's not going to tell you the degree, it's just going to tell you how will it feel. Is it something that you should wear clothes or less clothes? So again, whether it's a classification or a regression task, it's a business question that needs to be answered here during the problem formulation by the actual people who are using the service, right? Now, let's go back to a final discussion about regression and classification. Object detection. Do you think it is classification or do you think it is regression? Which one is?
More of classification, because we like understand if an image has a cat or a dog or science and so on.
Can you repeat that? I did not hear you very well.
Yeah, can you hear me well now?
Yes. But
yeah, I think it's more of a classification task because we need to classify objects mostly in object detection.
Right. So if I say there is a car in here, I am classifying this object as a car.
And maybe regression because of the position of something.
Exactly. Plus the fact that I am selecting the location of the object. So I'm doing both classification and regression at the same time. And that is object detection. So if you are good with classification and you're good with regression, object detection is going to be a very easy lecture for you. Now let's go to the first model that we will discuss, which is the linear regression model. So the linear regression model is extremely important model. Whatever you will be doing, whatever you will, be building for the company, always start with a linear regression or a very simple linear model as your baseline. So it's the first thing you think of. This is what you can do by default. And any model that you will be built just must be a bit better than linear regression. So that's your baseline. That's the first thing you should think of. And that's the first thing you should build very quickly. So the important thing about linear regression is it's able to do a mapping from one concept to another using a simple, easy to understand formula. So for example, if I ask you just a quick question, you probably already know this. So if I say my height is, or let's say Vladimir's height is 180 centimeters. Can you give a guess what is his weight? So you are guessing without knowing, for example, does he go to the gym? Does he eat lots of sweets? Does he eat only, vegetarian food? Is he more on vegan side or is he more on something else? You don't know any of these information. You are just guessing the weight from the height. Very easy guess would be how much?
18.
Just 80 kilograms, right? Very basic guess. We're not making any assumptions about this person. But even this 80, even if it's not correct, he's going to be in this range, right? He might be, 75, or he could be 85. But already with this guess, you will be very close to correct for, let's say, 80% or 90% of the people. You are correct on the guess for their weight, right? So this is what the power of linear regression is useful for, because it allows you to build a very easy guess about concepts that you don't know using concepts that you know, right? So it's able to map from the concept of weight to the concept of height. And this is extremely important. For example, you are, I don't know, you are a recommender system, and you want to make some guesses about what people like in order to how do we say this? To provide them with some recommendations on what they should buy, what they might like. Maybe you realize that they have a car. Probably they like, you know, the new what is that called? Fast and Furious, something like that. So very basic decisions can be made using linear regression. So this is why for recommender systems, always try something very linear, very simple, right? Very basic. Next step is logistic regression. Logistic regression is an improvement over linear regression, but it's a very simple improvement, right? So for logistic regression, for linear regression, you are in the regression field. For the logistic regression, you are in the classification field. You are trying to classify something. Very simply, linear regression could not be used for classification because it can go up to, you know, 1 billion, and it can go into minus 1 billion. So it's very hard to interpret something that goes like this, right? So you could say, I put it in the 0. Anything that is predicted above 0 is class positive. Anything under 0 is class negative. You could do that, but what does it mean to be 1 billion versus 1? What's the difference between them, right? What does that mean? This is why they introduced the concept of logistic regression, which uses this sigmoid function. Sigmoid function allows us to get more interpretability from our model because it constrains all the numbers of the output to be between 1 and 0. Can somebody tell me what other concepts are between 1 and 0?
Probability.
Probabilities, right? So probabilities are a very easy thing for human beings to understand because they're very logical for human beings. This is why logistic regression is a very logical thing to use, because it allows you to get something easily interpretable by a human being, right? So this is why we use the logistic regression for classification. It's simply just a linear regression plus a non-linearity that is basically just allowing you to have something to interpret plus an if statement. So you add this plus the sigmoid plus linear regression, and you get yourself the logistic regression. Very basic model. Allows you to also do the mapping, but instead of mapping from, you know, something like the height to the width, to the height to the, what is the other one? Height and weight.
Weight.
Yes, sorry. From the height to the weight, you could take something from the height to whether this person will be comfortable sitting at a business class, or will this person be able to sit comfortably in an economy class, or will they prefer the business class, right? So knowing the height of the person, you can try to make the decision. Should I send this person an ad about business class? You know, this person is very, very tall and he's going to be very uncomfortable in economy class. Let's tell him that for just 50 euros extra, you can have a seat very comfortably in the business class. Probably he will enjoy it, or let's say 30% will enjoy it. And there you go. You used some basic logistic regression model to make decisions that influence the sales of the company, and you made money from that. Very simple model and easy application everywhere to make money from it. Now let's go to the next level, right? So now we're going a bit deeper, a bit more complicated, but we're not changing anything. We're just changing the way of thinking about this concept. So here we will speak about perceptron. Perceptron is basically a logistic regression. Exactly the same calculations. They do exactly the same thing. They map from a group of concepts to another group of concepts. That's all they do, right? So perceptron, this is the basic building block for a neural network. The neuron, this is the neuron. It's called perceptron because when it was built, it was a very simple thing, but now you can think of this as just a neuron. Takes some inputs, multiplies them by some weights, and does the sum. Just like your linear regression does, just like your logistic regression does. The only difference is, or similar to logistic regression, it will apply an activation function after it does the sum. So instead of allowing the values to go from minus 1 billion to plus 1 billion, it will apply some activation function to limit the numbers between 0 and 1, or between minus 1 and 1, or however it feels that the number will be most interpretable. So the perceptron, or the neuron, is exactly like a logistic regression. If you understand what logistic regression is, neurons are very simple concepts for you to understand. Now that we have the perceptron, we can do a little bit more. We can put it on steroids and we get the multi-layer perceptron, or the neural network. Remember when we said that you can take something like the height of a person, and from that you can make the decision whether to give them information about business class and promotions. A better way to do this would be with neural networks and go much deeper into this modeling, and you will have something like the weight or the height, and another one would be whether he is vegan or not, right? So dietary things that he likes to eat. And then another one would be the salary of this person, or whether they are rich or not. From this first information, you said, yeah, this person would really like business class. So now you mapped it to a potential business class client. Combining it with other information, you get some other new information. Say this person is rich, so he is, more able to afford this one. This person is, he is Muslim, so he only eats halal food, or some other information. You just built that mapping in this layer, and then you combine all of these concepts into another set of concepts, saying that this person will be very interested in the business class, but not any business class, only the business class that goes into Turkey for a vacation. Oh, then this is good, then we can do it. For if you are trying to combine more concepts, say, for example, this person is Muslim and we are in Ramadan, right? So this person will be very likely to pay for for some service related to Ramadan. So you will combine all of these concepts together, and in the output of the neural network, you're able to get a much more deeper understanding of your client and provide that client with a better service that they are willing to pay for a little bit more. They will be happy. Your business will be even happier because we're making a lot more money. And you did that very simply by combining hundreds and hundreds of logistic regressions together, right? So logistic regression, it's very simple. Building a neural network is very simple concept too, because it's only about getting hundreds of logistic regressions working together in order to give you the most deepest understanding of your client or of your sample or of your data to make better decisions, right? Better decision means higher accuracy or higher precision, higher recall, higher F1 score, lower MSE. So you have hundreds of ways of defining better precision or better results. But the goal of this is to remember deeper architectures are very simple models. They're just big logistic regressions. That's all they are. Nothing complicated, nothing fancy. So I know this is not a good introduction or a full introduction to what neural networks are, but it is a very simple one that anybody can understand, right? So the goal of this was not to teach you about backpropagation or how to train neural networks and all of these things. We will see these things in the lab, but the theory, I'm sure you guys have already done this. Now this was just about giving you a simple intuition about how to think about neural networks and how to decide whether to go from a basic logistic regression into something more complicated like a big neural network, right? So don't make the jump directly to the neural network. always start with a logistic regression. If that logistic regression is good, it's going to be even better than your neural network. You don't need to go to your neural network. So do you have any questions about neural networks, logistic regression, linear regression, perceptron, multi-layer perceptron, and all of these concepts? All clear. Yeah, then that's good. So let's take now a break of, let's say, 15 minutes. Eat well, rest well, do some push-ups, jump a little bit so that the blood is moving. And then let's come back after 15 minutes and finish the lecture. All good. See you soon. Hey, everybody. Are you well rested? Nice. So let's go and finish today's lecture, and we will see whether we start the lab today or maybe we start the lab next week if we finish a bit late. Anyway. So far we have seen multiple things today. We've seen, the course structure overall, and then we spoke mainly about the steps that we have to take in order to deploy our machine learning model, going all the way from the first part, which is business problem formulation and, basic ML pipeline and project management tools for machine learning. And then we spoke a little bit more detail about that pipeline on the questions that need to be 100% asked before any coding must begin. And all of these questions should be, as we said, asked and answered into a single document. So for example, for your company, you might be using Notion, or you might be using, Confluence Pages, but these questions must all be answered beforehand and must be in a single document that everybody has access to and everybody has to agree on, right? So this is something that you will be having lots of discussions about, especially with business people. They might tell you, oh, we did not accept that, or we did not discuss this beforehand. So it's very important that everybody is involved in that process and that everybody agrees on the steps that we are taking to get the project out there. Again, we finished that part and we started the discussion about basic machine learning models such as linear regression, logistic regression. And then we've seen how logistic regression and perceptron are basically the same thing. And how can we go from a single perceptron into multi-layer perceptron just by putting hundreds and hundreds and hundreds of perceptrons together and stacking them in this order. Convolutional neural networks will be the rest of this lecture. So this one will be something pretty easy because you have already done this, I'm sure. But just to, to discuss this, I'm going to be sending you this beautiful video. It's a YouTube video, very nice. I'm not sure if you guys can see it. Let's see. Again from scratch. Can you see everything? You don't need to hear it, just see it. Right.
Yeah, we see.
Nice. Here we go. So as you can see, you take an image, input image. This is your kernel, and the kernel will be sliding through the image. So sliding from this part through the image, and then generating some output. So it basically combines 9 pixels into one output, or it maps 9 concepts into one concept. And this leads to a activation feature map. This is the output of a convolutional layer. Again, you take an image, outputs an image at the out for that convolutional layer. And as you can see, this is what we call the activation feature map. This is the input. This is the activation feature map. And this is the application of one kernel in that layer. And now we will see that we don't have just one kernel in each layer, but we have multiple kernels in each layer. All done. We finished with one kernel. We go to the next kernel on the same image, right? Same image will be processed by multiple kernels. So the same convolutional layer will have multiple kernels. Most of the traditional computer vision models that you'll see will have the same size of kernels. So you see here 3 by 3 for all the kernels inside that layer, but you could have some exceptions. And here we have another image outputted from the same input on the same layer, but we have now multiple, as you can see, convolutional feature maps or activation maps. So here, for example, we have, 4 or 5 different activation feature maps for that class. And then they will all be processed together. You see all of these, they get mushed into the same, let's call it matrix. It will be an image, but with 3 dimensions, height, width, and number of channels. And now this 3 by 3 kernel is not only going to have 3 by 3, but it's going to have 3 by 3 by the number of channels. So even the kernel will now become a 3-dimensional kernel. And each 3-dimensional kernel will generate a single convolutional feature map. Another 3-dimensional kernel will be applied to all of this 3-dimensional convolutional feature map to give us a single image like this. We apply it multiple times. We do some here. What we did was just removing the negative features, as you can see. So we removed a little bit of the negative features. This is the step of activation. And now, as you can see, we took this and reduced its size. This is what we call as max pooling. I'm sure you already know it. So it just reduces the size of the image, hence reducing our computations, reducing our calculations, making the speed much higher, reducing the size of the model. It does a lot of good things for us. And then the final step would be the actual predictions and giving the probabilities for each class. So this is the, what is it called? The how to apply convolutional neural networks on an image. We have seen the whole algorithm in motion, but now let's actually see it happening. So here what we will have, for example, an image. This is the input image. It could be one-dimensional, or sorry, it could be one channel like this, or it could be multiple channels, like, for example, with RGB or colored images. These images like this will be matched with a kernel of the same channel size as the input image. So for example, here we have just one channel. So our kernel has one channel. If we had, for example, what is it called? A RGB image, meaning a colored image, we will have 3 channels. So this matrix and 2 other matrices behind it. Same thing for the kernel. It will have one like this and 2 other kernels behind it, and they will be applied pixel-wise, right? This first one will be applied to the first one. The second kernel layer will be applied to the second channel layer. The second channel layer of the third channel layer of the kernel will be applied to the third channel layer of the image. And then everything will be added. So in this case, we have only 9 numbers to be added together. If it was, again, 3-dimensional, then we will have, I don't know, 3 by 3 by 3, which is around 27. So we will have 27 values. Again, just immediate sum, and we will have 1 output value. So multiplication, lots of multiplications, and then just 1 sum, and you get your output. So here, this is kernels. Basically, we will go a bit into depth about them, and especially about 2 concepts that are extremely important: padding and stride. So here for the padding, for basically our kernels, we will have this, and they will go through the image like that. One problem that arises is when you are training, for an image. Let's do some drawing. Not sure if I can do this well on the iPad, but let's try. A whiteboard. Here. Let me take it here to the iPad. You guys can see it? Let's see. So basically what we will have is the following, right? We will have one image of 1, 2, 3, and 4. 1, 2, 3, and 4. So this is our image. Let's imagine our kernel is pretty small, like this. 1, 2. This is our kernel. Now let's count how many times we see each pixel. So this is the picture. For this, let me change the color. Yeah. Let's go back. So the first time we will apply it to this region, right? I will write something here very useless, but don't look at it. So here we will apply it to this region. How many times did we see this pixel? 1. This one also 1. This one also 1. This one also 1. Very well. Now let's erase this one. and apply it for the second time to the pixel right next to it. So here we will apply it to this region, right? So can you tell me how many times did we see this pixel? It becomes 2, right? This one also 2. This one, 1, and this one, 1. So every time we see a pixel, we count it. Let's erase it and go to the next one. Here we will apply it on this region. And we have 1 here, and these become 2 and 2. Let's erase, sorry. Yep. And let's apply it again. So we cannot go here, right? Because this one is impossible. What we will have to do is we go back to the start and come to this place. How many times did we see this pixel? Twice, once here and once here. This one is 1, this one is 1, and this one becomes 3. So we already can see that we have some pixels which get visited only once, some pixels which get visited very frequently. So for example, this pixel right now, how many times did we see it? 4 times. This pixel, we saw it, so far we saw it only 3 times, but soon we will see it also 4 times. This one becomes 2 and this one becomes 1. So here, for this pixel, will it ever be visited more than 1?
No.
Absolutely not. But for this pixel, we are including it in our decision making 4 times. So some pixels get included 4 times, other pixels get included only once. This is not fair, right? So in cases where, you know, the content in the center here is the most important and you can ignore the surroundings, that's okay. But if it's not the case, and for example, you have here an image, and let's say you have a kid in this region. The kid in this region is very important for you, right? You don't want to ignore him. Hence, we cannot use this technique immediately. We need to fix this or find a solution to this problem, right? Because these pixels in here, we only see them once, whereas these pixels, we see them 4 times. Not fair. The solution is called padding. So padding allows us to get this pixel, this is the image from before, right? Like this. And what we will do is the following. We will include extra pixels around it, very useless pixels. They have nothing, no information here, just zeros. Just zeros. Everything here is zeros. Zeros, zeros everywhere. All of this is zeros. But just including this amount of pixels will allow you, or this padding will allow you to see this pixel in here 4 times also. Not just once, but 4 times. So all the pixels in your image will be considered equally, and all of them will be treated in the same manner. So no assumption on the importance of each individual pixel. So now let's go back to the lecture. And ta-da. So this is padding. So as we said, padding allows to fill basically pixels which are added around the input. For one, the first one is augmenting the size of the output. For example, if you are building a very, very, very deep neural network, that at each layer, you will be losing some pixels. Each layer, you will be losing some pixels. Each layer, you will be losing some pixels. By layer number 50, your image size is going to be 0. So padding is important to maintain the size of the output, augment the size of the output. And the second goal is to increase the focus on the borders and not just focus or visit the borders once. We will visit the borders 4 times, just like the other pixels. Now for stride, this is the next component that we need to think of. And for stride, it basically just represents the jump side of the kernel inside the original image. So here, if we watch this video, so we see the stride, it was here, then it went here. Stride is equal to 1. We jump by 1 pixel. For some reason, I want to jump by 3 pixels. Nobody can stop you. You can do it with the stride. If you do that and jump by 3, we will reduce the calculations drastically. We will save a lot of time. We will save a lot of work, but we will do less calculations and hence less deeper understanding. So let's go back to the whiteboard again and see what happens. So here, 1, 2, 3, 1, 2, 3. Let's say our kernel size is 2 by 2. So this is 2 by 2. This is 4 by 4. Now let's calculate the output. So we apply it first here. Okay, let's just. Opa. So we start by applying it in this region, right? And we get one output value. We jump. Sorry. Okay, we jump and apply it here, and that gives us a second value. We jump, apply it here, and gives us a third value. We jump, apply it here, it gives us one value here, and then one value here, and then one value here. We jump again, and we are at the end, and it gives us a third value here, and then we jump again, and then we jump again. So we arrive at a 3 by 3, right? Started input image was 4 by 4. A kernel of 2 by 2 with a stride of 1 leads to a 3 by 3 output image. So we have some calculations related to 3 by 3. So this is the O notation, O of n, remember? This is your n. So this is n squared. Now, if we go to a 4 by 4 and we maintain the 2 by 2, but instead of jumping or the stride equal to 1, now we make a stride equal to 2. Let's test it. Nice. Let's draw it. We apply once, gives us 1 pixel. We jump by 2, so we don't jump here, we jump here. So now we go to this place. How many pixels we get? Another one. Can we jump here? We cannot. Can we jump here? We cannot. So we finish. We need to go back down. Can we jump to this region? No, our stride is 2. So we have to jump to this place. So that gives us 1 output. We jump again by 2, and that gives us a final output. So now we have our output is equal to 2 by 2. So as you can see, the more we increase the stride, the less calculations we have to make, the smaller the output is, and basically the smaller the overall neural network is, and the smaller the faster the neural network becomes, right? So if you are building a neural network for, I don't know, mobile apps or something like that, you could try to experiment with a higher stride value to reduce the calculations and make it much faster, or make it even real time if possible. Nice. So let's go back. Yep. So these are the two concepts that I would like to, I wanted to make sure that all of us are here or, understanding. So padding and stride. Now this formula is extremely important because this formula will definitely be part. Okay. And won't we lose some information? Yes, we will. We will lose some information, some combination, right? Let's go back to the drawing board. We are going back to the drawing board anyway. Let's go back to the drawing board and see that, right? See that in actual real life. Yes. So let's say for some reason, let me bring back this one here. Here. Yep. So let's say we have the image like this. Yeah. And when we were applying our kernel, we applied it here. So we took into consideration the combination of this pixel with this pixel, with this pixel, with this pixel. And then we applied it. So let's keep this. Not sure if this is doable, or I will draw it again from scratch. Yep. Next step would be to go to this place with stride of 1. So now we are taking into consideration the combination of this pixel with this pixel, with this pixel, with this pixel. And then we go to a third iteration. And we apply it to this region. So that means we are taking into consideration the combination of these 4 concepts together, right? So for example, when we were speaking about, mapping from things like height and salary into business class optimizations or recommendations, we were combining different features to get an output. Same thing here, right? We are combining this pixel here with this pixel here to make a certain decision. But when we use a stride of 2, what ends up happening is we only combine this pixel and this pixel and this pixel together. And then the next side, we combine this pixel, this pixel, this pixel, and this pixel. So we lose this combination of pixels. We lose the calculation that could have happened from these pixels. Yes, we reduce calculations, right? But that might lead to less information being extracted and bad results. Now, yes, you could argue that we will have multiple, what are they called? Multiple executions of, what are they called? Convolutional layers that are consecutive. Yeah, consecutive executions. And at some point, we might have a combination of this pixel and this pixel and this pixel and this pixel, but at a much higher level. But you will not have it at this specific level. So you will lose this calculation, you will lose this information. It is a trade-off, of course. So we are losing some and gaining, we're losing some accuracy, but gaining some speed. And this is what's going to make your life a bit harder, or make your life more useful, right? So basically your whole job is to make these trade-offs, make these decisions of, do I want a better model or do I want a faster model? Do I want a bigger model or do I want a better model? Again, so it's all the size. And if we apply padding of 1 4x4, we end up with 5x5 stride with 1, end up with 3x3, and stride is equal to 2. We did as we did with padding of 0 and 1, right? So we can choose either combo to end up with the same accuracy. Yes, but if you play with what is it called? If you play with the, what is that one called? Yeah, the padding and the stride, yes, you will have more, might have the same output size of 3x3, but definitely you will not have the same results as in both cases, right? So as you said, padding is equal to 0 and stride is equal to 1, or padding is equal to 1 and stride is equal to 2. The size will be the same, amount of calculations will be the same, extracted features absolutely not the same. So is it the same accuracy? No, you're never going to have the same accuracy. One might be better, right? Maybe this one is better, maybe this one is better. They are equivalent in terms of calculations, equivalent in terms of, space, more or less. Performance, on the other hand, nobody can tell you which one is better. So it's up to you to tune them correctly, and then hopefully one of them will give better results than the other. But in most cases, you're never going to get to this lower level of tuning, padding, and stride. Thanks to our friends at Facebook and Google and Microsoft, we already have some good architectures that we use by default to train our models, right? So for the majority of the cases, you're never going to be tuning stride and what is it called, and padding, right? And now we go to, thank you so much. Very, very, very good question, Vladislav. Now, number of output. What is the dimension of the output given the following equation? Input plus 2 padding, right? Because we're adding on both sides, minus kernel size divided by stride plus 1. Now, one good question would be, what is this? What is this thing? This thing just means the integer part. So for example, if you have 9.9, when you do this, it is equal to 9. If you have 9.0001 and you do this, it is equal to 9. Only thing you take is the integer part of the float value, right? So let's start. Let's try the exact situation that you have given Vladislav, right? So let's say we apply a padding of 1, so 2 times 1. We end up with a 5 with 5 by 5 with stride equal to 1, and end up with 3 by 3 with stride is equal to 2. So I'm assuming the input size is 5 by 5. The kernel size is, let's say, 2 by 2, and the stride is 1. Can somebody do this math really quickly? 5 plus 2 minus 2 divided by 1. It's a very difficult math equation. Yeah, 5. Now let's I think let's assume that this is 3. This would be a bit better. So let's do it for 3. Can somebody do this for 3? 5 plus 2 minus 3 divided by 1. Get your calculators ready. 4, hard math, very good one. We have a math expert here. So here we have 4. This is 4. The integer part of 4 is basically 4 plus 1, which is equal to 5. Now let's do the same math for a, what did you say, stride of 2. Okay, let's do another math, right? So 5 plus 2 times 2 minus 3 divided by 2 plus 1. This is going to be a bit harder, right? So 5 plus 4 equals to 9, minus 3 is equal to 6. 6 divided by 2, how much is that? I think we have Lenar.
3.
3, thank you. Do you confirm, Lenar? Yeah, we need Hazanov's confirmation. Yeah, he's not confirming. Still doing the math. 1, okay. I think, yeah, no. Think again, think again. 4, correct. So here we have 4, and here we will have, sorry. Here we have 4, and here we will have 5. So as you can see, playing with the stride and padding and kernel size will give you different output sizes. This task is pretty important if you're building, a neural network from scratch, and you will have to do the math really, really well manually to actually build a good architecture yourself for like specific tasks. So you're going to spend a lot of time tuning this K, P, and S, especially if you are, more than just doing a classification task. You're doing, as we said earlier, things like variational autoencoders, and you're building the encoder side and the decoder side. So basically, in these situations, stride, padding, and kernel size become a question that you must answer yourself, and it just takes a lot of manual calculations. For now, we took some very easy numbers, and I'm thinking you guys were able to do the math pretty easily. but hopefully in real life, things might be a little bit harder, right? Just a little bit harder. So now let's go back to the lecture. So this is the formula that we use to basically decide the size, or not decide, but calculate the size of the output. And now we go to that last concept that we will discuss, which is pooling. So pooling is a technique that is very similar to Stride. It just allows us to speed up a little bit the calculations, reduce the size of the image, hence reduce the calculations, make the model smaller, make the model much faster. So Stride or pooling is very important as a concept, but it is exactly the same thing as Stride, so you could play around with it however you want. Now let's see. Again, if you just to make sure, playing with pooling and Stride is not always going to give you the same calculations and the same accuracy. So it will give you the same size at the output, but not the same accuracy, right? So it's up to you to see which one is better in terms of accuracy, whether to increase the Stride or to keep Stride at minimum and then do max pooling. That's up to you to calculate. But again, it's a trade-off whether to actually keep a Stride of very low number and then do the max pooling, which will result in more calculations, or to just do Stride much bigger immediately and no max pooling needed. So many decisions to make, huh? Let's bring it back and let's see what max pooling does. So let's say we have this image. Did you already study max pooling with Professor Khan?
Yes.
Okay, nice. So let's say you have this. Can you give me the max pooling for a kernel with size 2 by 2 and Stride is equal to 1?
Yes, I can try.
Go ahead.
So output kernel should be 3 by 3. First of all, yes. And so I'll go from left to right, and it will be 4, 9, 11, 4, 8, 11, and 3, 3, and is it 0? Yes, so it's 1, should be.
1. Very well, very nice. So you guys are experts in max pooling. So again, max pooling is a very simple technique. It's very nice because it has no, what is it called? It has no parameters to learn, right? So it's not something like, let's say, what is that called? Like CNN layers, where you would have parameters, you would have weights. You don't have any weights for max pooling. So max pooling is almost free in terms of derivatives or training. It's very good for that. So it doesn't contain any weights. You don't contain any, so in size of the model, it is equal to 0. It's just code that gets executed. It's just a function that gets executed. It's not an actual data structure that is maintained or something that is being tuned through backpropagation. It's something that gets immediately executed, just taking the maximum out of a couple of pictures or out of a couple of numbers. So now let's go back to the lecture and finish the lecture immediately. So here is the example of kernel size of 2 by 2 and a Stride of 2. So here we apply it here, we get 5, and then we jump by 2, and here we get a 9. We apply it in here and we get an 8, and then jump by 2 and we get a 9. So a very simple concept, reduces computations, reduces calculations, reduces the size of the output, makes the model much faster, but it doesn't lose that much on accuracy. But it does lose on accuracy. So not that much, but it does lose a little bit. Now, we're not going to go too much in depth about convolutional neural networks for three-dimensional images, but just remember, three-dimensional data is pretty simple. For example, videos or heart MRIs or anything that is like three-dimensionals with multiple channels, but not because of the number of channels is like 3 or colored channels, but multiple channels because of the data itself has information about depth, right? So we have, for example, MRIs. If you have ever, went to the hospital and did some MRIs, you'll see that they do a three-dimensional image of your brain or of your heart, and they can see slice by slice what is happening inside your brain. Now, we're not gonna speak about, the temporal information for videos and how to combine that into a model and multiple seconds and stuff, but we will just speak about the concept of three-dimensional convolutions. Three-dimensional convolutions are very similar to what you already know in two-dimensional convolutions. Instead of a two-dimensional kernel, have a three-dimensional kernel. Instead of two-dimensional data, you have a three-dimensional data. And instead of a two-dimensional feature map, you have a three-dimensional feature map. So very easy, you apply it, apply it like this, and then you stride, not stride, but like, yeah, stride. You slide, you slide through the image like this, and then you slide next one and next one, next one, It's much bigger than the two-dimensional CNNs, and the results are not always that good. So there are always some techniques that basically help the model go faster for specifically for videos. And if you're working with three-dimensional medical data, then there are specific models to work with that are based on three-dimensional convolutions, but they are like some modifications. That's all you need to know for this course to get started with the lab and with the quiz and the everything else. Do you guys have any questions so far about what we have seen?
No.
All good. So from my side, I think this is it for the lecture. Let's see what the time is. I don't know how to read the time because it's
We have 45 minutes more.
okay. So for
about 45.
Nice. For Monday, you start at 12:50, right? And then you go to till 14, how much? 20?
Until 14.
Until 14:20 or 14?
Oh, sorry, until 16.
Until
like from
16. Yes.
Yeah.
Yes, that's much better calculation. So from 12:50 till 16. And then we have the next type of lectures on Saturday, right? Let me just confirm. This is a bit confusing for me because they keep changing it. Saturday from 16:10. Saturday from 16:10 till. Oh, thank you. There's an image. Okay, nice. I don't see us. Where are we? AML online. Okay. So AML online is from 15. Okay, this is new time scale for me. When is this? This is for Saturday or for Monday?
It's Saturday.
For Saturday. So they changed the time?
Maybe.
Okay, wow. Yes, absolutely. You are correct. They did change the time and they confirmed it with me also, and I forgot. So let me edit this. Yep, absolutely. So let me just pin these two messages so that I never forget them. Okay, we have two pinned messages. So now I can easily go back to these numbers and see them. So for now, we have 40 minutes left. During these 40 minutes, we're definitely not going to be able to go on the lab and actually do something useful in the lab. So let's take 10 minutes break and come back and we will discuss the projects, right? So we will start discussing the projects. As we said, this course is 100% project-based course. It's not something that you will do a lot of, theory in. This is something that will be based on your individual work and your projects. And for today, we will start discussing what projects each individual person is aiming for. And hopefully in how many weeks? This course is on about how many weeks does this course contain? Any information?
About 7.
Yeah, 7 weeks. So you will definitely at least need a month, 4 weeks to actually get something good for your projects. So for that, we will start today the discussion about what are the different projects. You will start discussing things like, who are you going to do this project alone? Are you going to do this project with a friend? Are you doing it in groups of 2 or a group of 3 or a group of 1? And after that, we will start to discuss the actual topics, and we will grade the topic discussions, and we'll finalize basically the topic discussions. Let me give you a date. We are 5th of June. 12th of June, we must have the projects set up for each individual student. So each individual student must know what their project is by the 12th of June. And hopefully you'll start working on that too. After 3 weeks, so basically 12th of June, and then 3 more weeks would give you the 3rd of July. Yeah, 3rd of July, you will have the mid-evaluation for your project. This is basically a presentation that shows basically your work. What have you done so far? What are the problems you're having and everything else? So you'll have a quick presentation. This presentation will be 30% of the project grade. And then on the final week of the course, we will have the final exam, of course, and the final presentations. The final presentation is going to have 70% of the project grade. And that's the one that we will have like the most in-depth discussions and everything, right? So I guess, yeah, that's it. Do you want to take a break now and then come back and have these discussions? Or do you want to take, or you want to discuss this right now and then basically finish the lecture a bit earlier? The second one.
Can we maybe shift the break to the end of the lecture and optimize our time?
Absolutely. Let's do this. So let's start with right now with the spreadsheet about the topics. Do you guys know each other already? I'm assuming, right?
Kinda, yes.
Nice. So I will share with you a Google Sheets where you should just go, put your name, and if you are, in a group of 2 or a group of 3, and you already have decided to work together, you can discuss this right now. Just put the name, topic, name. So your names, the topic names, and a little bit of a discussion about things like, the students that are participating. So the background, right? So just a quick background saying things like, I am from data science, or this one is data science, software engineer, or this one is just a data scientist purely, stuff like that. Topic name, and another one would be whether it is research / industrial project. Okay. I will give you some different, project possibilities, let's say, or project options, maybe. Let me start sharing the list. Yes. So I will share it on, what is it called? Telegram. Project ideas for computer vision. Any idea that you have, you could use. So anything. So for example, if you guys are interested in those new things like, oh yeah, I forgot about this dude, Mustafa Kira. Did you join Mustafa Kira? Who said? Okay, so yeah, sadly, he did not join us today, but hopefully next time. Yeah, this will be only for the students who are taking the course. Okay, nice, Mustafa is here. So this will be only for the students that are taking the course as a graded course, right? So if you're not in the graded course, you could put your name and everything, but just like specify that it is not graded so that I don't like, you know, put some pressure on you to finish it fast or anything like that. This is like completely optional for you. As we said, the project proposal or the project guidelines that you have seen right now, this is from like an old projects or the old computer vision course that we did with Professor Fahim. And here you will see different, just different ideas. Don't look at it at any information level, just look at the ideas or list of topics that you have. These are the topics that we will be discussing. You could choose anything from here that you want, or you could choose your own project. And I prefer something that somebody who makes their own project idea that will be evaluated at a much nicer or much, much nicer. Let me, this much nicer grade. So you could do things about basic, you know, computer vision, or you could do, you know, object detection. You could do something research in computer vision. If you are already working on a thesis related to the field of artificial intelligence, then you could just use your thesis. If you are doing some research somewhere, then just go ahead and do that. Anything that you are already working on can be taken into consideration as a project for this course. And if you want to, you know, go with, as we said, prompt engineering, you have like a specific problem in mind, and you would like to just do that, solve it through prompt engineering, then definitely just show me the steps that you took. For example, project formula, you know, business formulation, problem formulation, going through the collection of the data, maybe fine-tuning your own small ChatGPT, and then building the what is it called, the prompt engineering strategies for it. We will certainly have a lecture or a quick lab about prompt engineering, some of the tips that you might use. Again, maybe something that I forgot to mention, during the QCM, what is the QCM? During the midterm and the final exam, it's completely open book, so you can access all your lecture slides, access any notes you have, access Google, Yandex, access what is that called, ChatGPT. If you are using something like Bard or you're using Notion AI, anything you are using is allowed. You can do whatever you want during that midterm. Just do not communicate with your friends. Other than that, you're all good. Maybe one project or one person could be interested in building a ChatGPT based on the for example, the YouTube video of our lectures. Somebody could take those YouTube videos, get the transcripts, very easy, something very easy to do, and then train a ChatGPT specifically for our course that he can use to answer questions during the final exam and the midterm. So this is like a project to help you cheat. And if you do it, then I would be very proud of you. First of all, that's good. Cheating is nice. And it will be counted as something that helps you for the final exam and something that helps you for your, what is it called? For your project, right? So again, the possibilities are endless. Please do something that is completely, you know, new, something that is daring. Don't think of something that is that has been done too many times and that is not unique, preferably for your future, right? Not for the course. Nobody cares about the course, right? As I said, everybody will get an A or a B. So the grade of the course is not important. What is important is having something to discuss during an interview with, with your interviewer, or having something to discuss or to put on your resume, and something that is interesting and gets the conversation going, right? So I had students working on anime faces. They would generate, different anime faces based on your face. That was pretty cool. I've had some people who had a startup that was working on, generative AI for fashion. That was also pretty nice. We've had students working on transcribing movies, not transcribing, but describing movies. So instead of saying just the text, now you have the description of the whole scenery, saying actor 1 wearing red clothes is talking to actor 3 about getting a divorce. So this was a very interesting project, and they've worked on it, and it's been pretty nice, right? In-game ChatGPT that can grant hidden quests. Oh, wow, that sounds a little bit too complicated, right? So you will need to have access to the game's code to do that, but seems cool. If you can do it, that would be amazing. Don't forget that all these models must be deployed somewhere, either as a web interface, just like a quick web interface, and connected to a server. Minecraft. Awesome. Yeah, put any details that you want to put, right? Feel free. Go ahead, guys. Just start on it right now.
Sorry, I have a question about,
Yes.
may I ask it?
Yes.
Okay. My question is, can our topics overlap between the different teams or not?
Yeah, but only if the topic is like super cool and super trendy and something like that. Yes, but if it's a bad topic, then it's okay for this course, but I would rather see you guys building something very unique and something very, very interesting. So yes,
Okay.
you can overlap, you can do the same project twice, but preferably for, building that uniqueness that can help you get, some masters, what are they called? Scholarships and stuff like that. Uniqueness is the most important feature to have.
Okay, thank you.
Perfect. So yeah, you could do, if you want, you could do some segmentation of some specific game. So I don't know, one of you guys here maybe like some games, and you could do some segmentation of the characters of the game, and that might help you do something else. I don't know. Completely up to you. And yeah, good luck. You could apply some reinforcement learning. I've had like some students who are building reinforcement learning models for specific games. That was pretty interesting. You could do, as we said, natural language processing. You could, I don't know, improve ChatGPT for Russian specific tasks. That would be cool. If you are already working on a startup and you would like to improve something in your startup using AI, definitely that would also be really nice and unique. So it's completely up to you guys. It's very important that everybody has at least their name on the list today and their background, right? So please do go ahead and whenever you see a zone that has nobody writing on it, just go and put your name, at least your background, and whether your project is going to be a research project, an industrial project. And hopefully by the next lecture, we will finalize all of these topic names and all of these topic discussions. Next Monday, everybody has started working on their project. Of course, you might not be an expert at what you're doing right now, but at least you will start doing what we discussed about, the pipeline of machine learning, right? So things like asking yourselves the questions that need to be asked, things like how can this be done? Are there already some other solutions doing this? Looking at these solutions, evaluating them. What do I define as a success for my project? Things like, what are the domain experts? Let's go and see. So for example, if you are, as you said, speaking about a certain game, Minecraft game, these hidden quests, then you could, just list all of these hidden quests and how to access them and stuff like that. Framing the problem, does it need machine learning? What kind of machine learning do I want? Do I want some segmentation, classification, just the basics, right? just the basics of what your project is all about. Definitely, I will share with you guys this. Anybody can view, anyone at educational team, anybody with the link can view. Let me verify. Can you guys see this? What is it called? See this? Those mind maps. Anybody with link can view.
Yeah, we can see it.
Nice. So now that you have the mind maps, you have all the questions that you need to ask to actually formulate a good project or a good machine learning project in general. Start by asking yourselves these questions. Data questions also need to be asked. And hopefully, as of next Monday, right, we will have all of these questions answered. And I might ask you to give me like a quick report, just some document, whatever you want. If you like using Notion, use Notion. If you're hardcore into Google Docs or Microsoft Words, just use those. If you have some specific note-taking tool, just use that. If you want to do it in Overleaf, super complicated, I love that. No worries about that too. Just give me a document that basically contains the answers to these questions in a very structured and easy to read way, right? So I want something that I can look at, see some pictures, see some diagrams. This is your main job. Your main job is to answer these questions in a very easy way and to build a report that any human can look into, understand all the context of your project, and hopefully this will be your first step into being, I don't know, project manager or team lead for a big data science project or big data science team. Okay. One cool thing to do is also for the data. For the data size, you can start, understanding, are there some, public data sets available? Commercial data, of course, you're not going to buy anything and it costs like hundreds of thousands of dollars. Probably you're not going to be spending that much on a project. Web scraping, that is also a very good option. But for you, the concept of private data, definitely you don't have like a company that has been generating data for hundreds of years now, but you can label data yourself. So for example, you are trying to segment data for some game, you can just play that game and take some screenshots from your own monitor or something like that and label the data yourself, right? So this is a kind of private data that you could use. Yeah, so other than that, let me check your topics. In the brainstorming message me if you're interested to work together, prefer industrial. Okay, nice. Since you are in the, for Polina, if you are in the brainstorming session, just put some random words. Go next to that topic name and put some random words that you want to put. Anything you want to work on. Segmentation for medical purposes. Anything that you can think of, put it here and let's keep it. Should participants of one team write their names in one row? Yes, yeah. If you are in the same team, just write it in the same row, right? Students in general, the backgrounds in general. Yeah, we have some data science and software engineering. That's nice. That's a good group. We have Ilnar, our mathematics genius. Just software engineering. Do you want to do it alone, Ilnar, or do you want to do something with some other people?
Imad, sorry, maybe I missed a little bit. May I ask a few questions?
Yes, absolutely. Go ahead.
Okay. What about our hard deadlines now? What do we need?
Yeah.
For example, I have some candidate from students for my team. And now we, for example, create some chat. What we need to do?
So for the deadlines, we have three major deadlines. The first deadline is the project proposal / description. Right.
Mhm.
This one must be done by Monday, next Monday. So Monday,
Next
that's
month. Okay.
yes.
Uh-huh.
This one must be done by next Monday. Very easy document to read, PDF or anything you want, just something that I can easily read through and understand your project, answer all the questions that we listed. The next deadline will be after 3 weeks from that, so the mid-evaluation. And that will be after 3 weeks from January 13th. So how much? January 12th, not 13th, January 12th. And then we've got 1 week becomes 19th, 26th, July 3rd. July 3rd, oh, wow.
26, yes.
26 or July 3rd?
The
Like-
end of 3 weeks, yeah.
After 3 weeks from Monday, next Monday, after 3 weeks from next Monday. So after a month from now.
Mm-hmm.
And then the project evaluation is in the final day of the course. Project final evaluation is on the final day of the course, right? So it will be even after the final exam.
Mhm.
Final lecture will be about this project. Okay?
Okay, let's understand. Yeah, we have a 3 major deadline. Next Monday, it's about choosing some topics, some proposal. Yes, about this. And as a result, we need to just write our group of our
Yeah.
teams, teammates, and just topic. Yes.
Yes, and the topic name, and as we said, a description, just any file that describes your project. Yep.
Okay, this file, do we have some rules of this? Some
And up to you, for example, to do it as a PDF, you could do it in Google Docs, you could do it in Notion. Just share it with me in like here, for example, on E. Here, for example, let's make a new column to the left. Let's call this the report document, and just share the link here. Share the link to your report in this place, in the report. Yeah,
Mhm.
just share it over there. I see it, and we're all good.
For example, can we maybe choose some so really huge or deeply problem? Maybe it's a little bit infinite problem, and try to solve it. As a result, we achieve some results, but it will be it's not fully completed for the task, or we need choose some problem for solving fully.
Yes,
Okay.
exactly. So if you aim for something really complicated and really hard to do, but you don't solve it fully, you will be graded much better than somebody who aimed for something small, but he solved it very easily, right? So aim as big as you want, and your grade will be as good as that size, right? So even if you don't do a good job, just the fact that you aimed for that is more than enough for me.
Okay, for example, I want to try solve some logistic problem for one of my project. Is it okay if,
Yes,
for example, I with my team describe some computer vision implementation here and blah 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 for solving it? Okay.
Yes, as long as it has a very clear definition of what the problem is it being solved by another person in a different way? So all of these things, just answer those questions in the mind map. And for me, it's more than enough. It's an amazing project. If the more complicated it is, the better.
Okay, thank you.
Perfect. Very good work, guys. Any other people need some questions? Maybe have some have some ideas that they want to throw for some topics.
what about quizzes? Will we have it each day?
No, not each day. We will have 2 quizzes. One, we will have it before the midterm, before the mid-project evaluation. So probably we will have it around end of June, right? And then the final, yeah.
So it will be like midterm and final exams.
Absolutely, midterm and final exam.
I see.
Yeah.
Thank you.
Thank you. Anybody has some questions or maybe some topics that we want to discuss? Okay, seems good. Then we can finish right now and we'll give you back like 15 minutes. Please remember to start working on this as fast as possible. And hopefully by next lecture, we will start discussing these projects. And on Monday, you must have the whole thing set up. Okay. Perfect. It's truly been a pleasure meeting you guys and getting to know a couple of you. And I'm looking forward to maybe getting to know the rest of you and seeing where you guys are from and knowing your cities and maybe Googling some of your cities. That would be pretty nice. And I'm really looking forward to seeing your projects. See you next week, everybody.
Bye-bye. See you.
Bye-bye.